This is GNN.
You ready?
Welcome to GNN, the Genetics News Network, your 24/7 coverage of your traits. And today's topic is brought to you by Lucky Genes. If you don't like these genes, you can throw the pair away and get a new pair. So far we've learned about one trait crosses. So you had one trait that was either dominant or recessive. Now we're going to learn about two trait crosses. How about we meet the traits right now? And the first trait we're going to talk about are the shapes of the heads. Hello, Mr. Alien. How are you doing today?
I am doing quite fine, although I will be coming after you and your planet. Do you understand? We're coming for you.
That's very exciting, Mr. Alien. Now, the alien head is one of the traits. You can have an alien head or you can have a normal head. So the shape of the head is one of the traits we'll be talking about today. Now let's meet our second trait. Our second trait is the length of the face. And today we are going to look and talk to Mr. Longface. Welcome, Mr. Longface. How are you doing today?
Hello, I'm kinda having a bad day. Can you not tell by my long face?
For our second trait, as depressing as it may be, we are going to have the long face as the dominant trait and the short face as the recessive trait. Now, let's go through a step-by-step account on how to solve a two-trait cross. So today we're going to learn about a two-trait cross, often referred to as a dihybrid cross. So let's get started. Step one is determining the traits. We already showed you the dominant and recessive form of each trait. Now we must assign two different sets of letters, one for each trait. Here is our example. So you can see we are using an upper and lowercase a. I like to use the first letter of the trait. In this example, we had an alien head. That is why I chose to use the letter A for alien head, dominant capital letter, and lowercase a for a normal head. Now let's look at the second trait, long face versus short face.
But why? I don't want to.
For the length of the face, we're going to use a capital L for long face and a lowercase l for short face. For this example, we now have four letters. An A for the shape of the face. The capital A is for
Alien head.
the lowercase a is for a normal head. The capital L is for the
Long face.
and the lowercase l is for the short length face. This is just a reminder that we've concluded step one now, where we determine the letters for each trait. Before we move on to step two, I just want to ask Alien Head a question. I want to know who his leader is, because that's pretty serious stuff if you're going to attack our country or our planet.
Our leader is a great alien who has supreme confidence. And here is a speech that he gave on our planet earlier this month.
We're bringing drugs, they're bringing crime, dying.
So let's look at this specific genetics problem. Here we are going to cross a heterozygous alien head, heterozygous long face, with another heterozygous alien head, heterozygous long face. Now we need to determine the genotype of each parent. Heterozygous alien head would be a capital A and a lowercase a, and heterozygous long face would be a capital L and lowercase l. So the one parent would be big A, small a, big L, little m. The other parent is also heterozygous for both traits, so the other parent would also be big A, small a, big L, small l. We need to do some foiling just like we do in math class. What we'll start with is we need to find every combination of A and L that each parent has. I like to draw arrows when I foil. I like to take an arrow from the big A to the big L, the first and third letter, and then the first and fourth letter. You can see I have arrows to each. And then after I draw the arrows to each, I put each combination of A and L right below the parent's genotype. On the bottom, we do the same thing with the second and third letter and the second and fourth letter. Here you can also see combinations of A and L. We have a lowercase a with an uppercase L, and then we have a lowercase a with a lowercase L. Since the other parent has the same genotype, we will use these letters A and L on the mother's side as well. Remember, we had 4 possible outcomes for a 1 trait cross. Now with a 2 trait cross, we will have 16 possible outcomes. So your Punnett square should look like this. Now that we have all the possible combinations of A and L for the mom and dad, what we need to do next is put it in our Punnett square. As you can see, we will put the mother on the top of the Punnett square or the side, it doesn't matter, just be consistent, and the father will go either on the top or the side opposite the mother. Now normally in a 1 trait cross we have 1 letter above each box. Now we have 2 letters above each box. The last thing we do with the Punnett square is fill the square in. You drop it down and sideways, and just like a 1 trait, we fill in. In the 1 trait we had 2 letters in each box, and now we'll have 4. The last step is determining the genotype and phenotype of our example. Let's look at our example, and let's look specifically at a uppercase A, lowercase a, uppercase L, lowercase l. How many of these do you see? I see 4 out of the 16 with the same letters. So you could do 4 out of 16, which is also 1 out of 4, which is 25%. For the phenotypes, remember we're talking about the physical traits. And for this example, if it has an uppercase A and an uppercase L, you're going to have an alien head and a long face. And I see in our example we have 9 of these. Another possible phenotype could be an alien head with a short face. In this example, we see 3 more. Finally, only 1 out of 16 will be, quote, normal, and that is because they have 2 lowercase a's and 2 lowercase l's. In conclusion, we went through this 6-step process, and if you do this every time, you'll do it right. In step 1, we assign letters for each trait. In step 2, we determine the parents' genotypes. In step 3, we foiled the possible combinations. In step 4, we place those combinations on the Punnett square on the tops and the sides. Step 5, you completed the Punnett square. Step 6, we completed the genotypes and phenotypes of the possible offspring inside the Punnett square.
Step 7 is taking over Mr. Blazik's class and the rest of the world. Remember my name.
Name.
Name.